Hello. Hello. Salutare. Bună ziua, Bucharest. So my name is Sergey Morenets, and I came to Romania to speak about effectiveness and code optimization in Java applications, because optimization and effectiveness is very close terms, because optimization is a process of improving effectiveness or performance. So, a few words about me. I am Java developer, I am Java trainer, I am Java writer. I wrote 3 books. I am founder of the IT Simulator site and courses called IT Discovery. I often speak at Java conferences, mostly in Ukraine. So this is the first time I speak in Romania. So let's start with interesting term like ideal or perfect code. Please raise your hands if you see ideal code in your projects. 3 persons. Yeah, great. Yes, you authored it. Okay. So what is the attributes of the ideal code? Yeah, such code should be testable, modern, flexible, maintainable, and so on. And the last attribute is effective. Effective or fast. Why I put it on the last point, last place? Because people often forget about it or remember at the last time. Why is that? It's very hard to determine the effectiveness on the stage of code review or design review. It's hard to define effectiveness in development environment because developers often work with a small set of data just to verify functionality or find an errors. It doesn't work with like 1,000, thousands of hundreds of records. Optimization is interactive. So it's almost impossible to gain big performance gain in one step. Optimization is little step-by-step process where you gain small performance. Effectiveness is hardware specific. So if your application is slow, what should you do? You buy more RAM, yes, or more productive or more fast CPU. However, effectiveness is the only aspect of the ideal code that affects your users. If your code is non-readable, non-flexible, non-concise, your users will not know about that. But if your application is slow or take a lot of memory, users will complain about that. What are most popular pitfalls in optimization? So first of all, premature optimizations is evil. Why is that? Because developers often optimize non-critical parts of the application, or the performance gain is about 1 or 2%. So that's not enough. However, the readability and flexibility would suffer. When developers try to optimize their projects, they forget that Java compiler, JIT compiler, JVM also can optimize their code. And the last pitfall that you cannot optimize what you can't measure. So how should you optimize? You should measure current code, then optimize it, and measure once more. Only after that you can be sure that your performance gain is big. How to measure? I think you often use this approach, class system in Java and methods current time millis or nanotime. Yes, very popular approach. However, what is my recommendation is use specific tools for that. So one of these is JMH. Its author is Alexey Shepelov from Oracle company. So this is a micro-benchmark framework. What means micro-benchmark? It means that it can measure in nanoseconds. It's a rather new framework. It requires some build tool, Maven or Gradle. It can measure operation time or throw output. It includes warm-up period. It's very important functionality. And it was so successful So it is now part of Java 9. So Java 9 will be released the next year, and GMH will be part of it. So what do you need to measure your code? Let's take a look at this function. So you need a function. You should put annotation benchmark on it. The function should not accept parameters. It should have returning value. And recommendation by authors of this library is that you should disable Turbo Boost. Why is that? Because it accelerates your processor dynamically. That can give incorrect measurements. So this is a warm-up period. What is it? Before GMH actually measures something, it executes your code like 100 of 1,000 times. Why is that? If you look at the measurement results, you see that first iteration and 10th iteration is very different in time. Why is that? Because when you execute your code more than 10,000 times, then JIT compiler starts working. It can optimize in your code, get rid of bytecode, replacing by machine code, garbage collector starts working. So if you want to measure in production environment, you should always include warm-up period, either by GMH or by your own facilities. So I will provide my measurements with such configuration, latest version of GDK, Maven, GMH. I have Intel Core i7 processor with 4 cores. Let's talk about Java compiler optimization. So that's very simple code. Yeah? And you see that there is an if condition and the print line is now executed. Yes, because there is if and false. Is Java compiler smart enough to just kick off all this code? If you take a look at the bytecode, you see that it's intellectual enough. So it just removes if and system out because it never executes. Let's take a look at another example. Yes, you see there is a function and there is a local variable value, but it's not actually used. Yes, we declares it, increments, but return 1. However, if you take a look at the bytecode, you see that all the code was compiled. Yes, there is iconst, iStore, and iInc bytecode instruction. Yeah, so this code cannot be optimized by Java compiler. Yes, and there is a similar function optimized by developer. Yes, we just removed all the local variables, and you see that it just contains iconst and iReturn. However, if you try to measure it using GMH, you can see that time is identical. Yes, what does it mean? It doesn't mean that iconst, iStore, and iInc are super fast. No, it means that JIT compiler, when it sees that local variable value is never used, it just kicks it off. And time is identical. Yes. And now I want to present 5 interesting optimization techniques considering Java. So how would you convert text into a number? Or how would you check that string is a number? I think one of the most popular approaches is using long class and parse long function or integer parse int. Are there any approaches? Yes, I think you can use regular expression. So you create a pattern, then you create a matcher, and just invoke match function. Which approach is better? How do you think? Which is more effective?
No, the first one.
First one, okay. If you try to measure it, you can see that long approach is faster. Yeah? For every cases like small or average or big text, it's faster, except in one case. If you try a check if a non-number is text, you see that regex it's about 20 times faster. So if your code, if you have a lot of cases when you check for non-numbers, I think you can optimize it using regex and not long parse long. Another replacement, yes. You have a task to replace 3 characters by space characters, A, B, and C. Not everyone knows that replace all function accepts regular expression, and we can optimize it using this approach. Yes, more simplified and similarly more effective. Yes, so we create a regular expression, and any of these characters will be replaced by space character. However, this code is more concise, but this is more effective. If you try to measure it, you see that yes, it's effective about 2 or 3 times. Yeah? So if you have similar functionality, you can convert it to regular expression and have a performance gain. However, can we improve it more, optimize more? Yes. So if we take a look at how replace all is implemented, you can see that it actually creates a pattern at runtime, creates matcher, and it works replace all. So what is the possible way of improving it? We can extract pattern into a constant, not to create it each time. Yes, and the only dynamic part is creating matcher and invoking replace all. What will be the performance gain? If we perform measurements, we see that performance is about 2 times better. So if you have often replacements, strings, yes, you can optimize it this way. Is there any developer that starts working on Java 1.0? 1.0. 1, yes? Okay. So if you started working at Java 1.0, you used arrays and primitive types. Starting with Java 2, you get collections, and Java 5, you get generics. Yeah, so for example, this code will be translated to the second code. But there is one difference. Difference is that generic types in Java doesn't accept primitive types. So you have to use not list int, but list integer, yes? And what is the difference? Difference is that each time your primitive variable I is auto-boxed into wrapper, yes, into object integer. And you have to create this integer, yes, and put into heap. Will be more or less effective. If you take a look at measurements, we see that, yes, it's less effective, about 6 or 10 times worse. Yes. So what is the proposal solution? Should we skip this generic way and back to the arrays? There is a very popular library called fast2til. Fast2til claims that it has the fastest collection ever in Java. So we can use the object array list type that is very similar to array list. Yes, this is called object array list type. And try to measure it. And we can see that object array list is about 2 times faster than array list. Yeah, so you need better performance, you can use fast2til. Can we optimize once more? Yes. Has anyone used Trove library? No one? Trove library provided collections for every primitive type. So if you have int, double, byte, and so on, Trove will provide the collection. And if we measure array list, object array list from fast2til and int array list, it's array list for int, we can see that it's faster than object array list. So if you have to store primitive types and you need better performance, you can use the int array list. Li4, yes. So what is the fastest Li4 implementation in Java? I think the most popular approach is stack. Yes, it's very known class. Another implementation linked list, which is also can be used as a stack. If you try to measure it using the push and pop operations, that's firstly push numbers and then popping it, we can see the fastest Li4 structure is RateDQ. RateDQ is a new data structure that appeared in Java 6, and it is specifically designed for the Li4 operation. It was optimized, So you need the fastest implementation of LIFO. You should use array the queue and not stack and not a linked list. Mapping. Let's assume you have an enumeration, for example, weather, like hot or cold or warm, and you have weather attributes, like temperature and pressure. And you want to create a mapping between enumeration and this object. So what is the most popular approach? You created a map, say hash map, yes, and key is enumeration and value is object. Can we optimize it? Yes. We can use not hash map and enum map. Why is it better? Because if we use enumeration as a key, we know in advance the number of keys, possible keys. It's not possible to inherit or create dynamic instance of enumeration. So if we try to measure performance, we see that enumeration is really faster. Yes. So you have cases where enumeration is a key. You should use enum map. So what is our conclusion? When you try to optimize your code, don't forget about Java compiler and JIT compiler optimization. You can optimize speed of your application and memory footprint. And the last one, if you try to measure it, don't create your own facilities. Try to use trusted ways like benchmark frameworks. That's all. If you have questions, I can answer. Yes, please.
In what conditions are JIT optimizations reverted?
Sorry, can you repeat?
In what conditions are JIT optimizations reverted?
Yes, there are very seldom cases then JIT compiler can make wrong optimization. Yes, however, after some amount of time, it can find it and revert it. Okay, another question? No one.
No, I think that's it.
Okay,
So, big round of
mulțumesc.
applause.
Thank you.
Thank you very much.